Hey guys, I just want to go over real quick a couple examples of how we would use rational expressions or rational equations to solve word problems. So we're going to start with the average rate of speed word problems. And I'm going to go ahead and read it and kind of explain how I got to where I did. Sarah biked for 15 miles at a certain speed. When she reached a flat road, she increased her speed by 5 miles per hour and biked for another 20 miles. If the entire trip took 2 hours, which equation can be used to find her initial speed in miles per hour? So I need to come up with something that's going to give me hours when I'm done. And so I know that if I do miles divided by miles per hour, I'm going to end up with hours. And the reason that works is because you remember if you have a fraction divided by another fraction, we put miles over 1, and we could do miles, and we would keep change flip, and so that's going to put hours on top and miles on the bottom, and I'm going to end up with hours as my result. Okay, I know that's weird, and it's okay if you don't understand it. Hopefully it'll kind of come to you as you're working on these problems. But the way I'm going to set this up is I'm going to do miles divided by the speed, or miles per hour, and I'm going to get hours as my answer. So, Sarah biked for 15 miles at a certain speed. So her first part of her trip was 15 miles divided by the speed that we don't know. When she reached a flat road, she increased her speed by 5 miles an hour. So speed's on the bottom. So she's going to do another section where she increases her speed and biked for another 20 miles. The entire trip took 2 hours. So now I have an equation that looks suspiciously like the equations you've been solving. So I need a common denominator, and I know my common denominator is going to be x times x plus 5. So what do I need to multiply each of these by to get that denominator? So my first one, I have to multiply by x plus 5 on top and bottom. So that's going to give me 15x plus 75. My second fraction, I just need to multiply by x on the top and bottom. So that's going to give me 20x. And then my third, I have to multiply by x times x plus 5 on the top and the bottom. So that's going to give me 2x squared plus 10x. Then once I get my denominators the same, since there's an equal sign here, I can cross off my denominators. So really, I'm left on this side. On the left, I have 15x plus 20x, which is going to give me 35x plus 75. And it's going to equal 2x squared plus 10x. And now I just solve for x like I normally would. So I'm going to subtract 35x from both sides. And then I'm going to subtract 75 from both sides. And I'm going to get 2x squared minus 25x minus 75 equals 0. And then I have to factor it. So if I factor, and I know that 2 times negative 75 is negative 150, and they have to add up to negative 25, I can use negative 30 and 5 as my two factors. And remember, when you have an a, you have to go back and divide by that a. So negative 30 over 2 is negative 15. So that first factor is going to be x minus 15. And then my second one can't reduce, so the 2 is going to come in front. I'll have a 2x minus or plus 5. Okay, so I have to set them both equal to 0. So I'm going to go over here, and I'm going to say x minus 15 equals 0. And 2x plus 5 equals 0. And on this side, I'm going to have x equals 15. And over here, I don't even have to figure anything out because as soon as I have to subtract by 5, I get a negative number. And remember, I'm solving for her initial speed. So I can't have a negative number. So her initial speed was 15 miles per hour. And that's pretty much all you're going to do for these. Number 2 is kind of weird the way it's worded, so I don't want to make it even more confusing. So I'm going to skip number 2. I'm just going to go straight down to number 3. And it's basically the same idea. John ran for 6 miles at a steady pace. Then he walked for 3 miles, decreasing his speed by 4 miles an hour. If the entire workout took 1.5 hours, which equation can be used to find John's running speed in miles per hour? So, remember, we're going to do miles divided by miles per hour. And that's going to tell us how many hours he was out there. So I know he started for 6 miles at a steady pace. I don't know what the pace was, so I'm just going to say 6 over x. Then he walked for 3 miles, so he did 3 more miles, decreasing his speed by 4. So I'm going to say x minus 4. And I know he went for 1.5 hours. All right, now I'm just solving for x. So I need a denominator that's going to be x times x minus 4. And don't let that 1.5 make you nervous. We'll figure that out. So I'm going to do the first one by x minus 4. So that's going to give me 6x minus 24. The second one, I have to multiply by x. So that's just going to give me 3x. And then the third one, I have to multiply by x and x minus 4. So that's going to give me 1.5x squared. And then minus 6x. Okay. So I can get rid of my denominators now. So I'm going to have 9x minus 24 equals 1.5x squared minus 6x. Going to subtract my 9x from both sides. Going to add my 24 to both sides. And so I'm going to get 1.5x squared minus 15x plus 24. All right, and that's a little nerve-wracking, but I can divide a 1.5 out of all of that. So when I do that, I get x squared minus, let's see, 10x plus 16. And that equals 0. So now I'm just going to factor what's in the parentheses. So if I do that, I have to have 16 as a result, negative 10. So I'm going to use negative 8 and negative 2. So this is going to be x minus 8. Oof. I'll write it over here. X minus 8, x minus 2. So that means my x's could either be 8 or 2. Now remember, we're solving for his initial running speed. Yeah, so we're just doing the initial running speed. And remember, his initial running speed eventually decreased by 4. So we can't have 2. 2 can't be our answer. So his initial running speed is 8 miles an hour. And you can go back and check this by putting 8 back in your original equation, because I would do 6 over 8 plus 3 over 8 minus 4 is just 4. And when I add those back together, I get 1.5. So there you go. All right, so there's your start. You have some practice to do, so just let me know what questions you have.